to track 2, reliable value delivery with latest technologies. The sponsor for this track is Solo.io. I take this opportunity and privilege to introduce the first keynote speaker for this particular track, Mr. Akshay Adsul, who will be taking us through the journey of enabling digital transformation with application networking. A brief introduction about himself. Akshay has experienced DevOps specialist with extensive experience in the IT industry across the globe. Currently based in Sydney, is skilled in CI/CD using DevOps tools, automation, Kubernetes, administrator of IBM middleware stack, and environment infrastructure management for cloud. He's also an eloquent communication skills with a flair for conducting trainings and mentoring the new hires. Ladies and gentlemen, let me take this privilege to welcome on stage Mr. Akshay Adsul. He will take you through the journey of enabling digital transformation with application networking. He is from Solo.io and working as customer success engineer. Let's give a big round of applause for him. Over to you, Akshay.
Thank you so much. All right, let's get this party started. Thank you for the lovely introduction. It's my first time here in Singapore, and I must say, what a beautiful city. Really gorgeous. I came here from Sydney, Australia, and it was really humid, but absolutely loved it. So this keynote is going to be about, obviously, enabling digital transformation with application networking. Now, we all know why, as a business, digital transformation is so important, right? If you want to stay relevant in today's global market, in today's economy, you have to be well equipped with doing those digital transformations. Now, what I'm going to talk about specifically is how application networking can help you achieve that digital transformation. And hopefully, by the end of it, you will sort of kind of gain an idea on how application networking can help you, how we at Solo can help you achieve your goals. So one thing I do want to highlight is do stick for the entirety of the talk. I have 2 special surprises for all of you in the audience. So 2 lucky people in the audience are going to get something special, but for that, you have to make sure that you listen attentively to what's going on in the talk. So without further ado, let me just talk about how this roughly 45-minute presentation is going to go. So we're going to talk about first about the cloud native digital transformation journey that's happened. We're going to talk about the key concepts and technologies in application networking. We are obviously going to talk about business impact. So what I've done is, I know that the audience might be a bit split. We might have technical people in the audience. We might have business people, right? So I have something for both sets of people. And then we'll sort of marry the two and talk about use cases and how Glue Platform can help you achieve this digital transformation using application networking. Now, when I started my career about 15 years back, monoliths, everything was monoliths, right? We would deploy applications as a big monolith stacks. And over the last 5 to 8 years, we have seen this transition happened from monoliths to microservices, right? Every organization who's trying to stay relevant is trying to do this monolith to microservices journey. And obviously, Kubernetes has become the de facto standard when managing these microservices architecture. I've been privileged to work on Kubernetes for the last 5 to 6 years, and I'm sort of glad and excited to sort of share my own learnings with you, and also how best you can use application networking in your digital transformation journey. Now, in today's world, what we've seen, I like to call it as cloud native 1.0, right? Over the last, like I said, 5 to 8 years, we've seen the advent of private cloud, of public cloud, hybrid cloud, multi-cloud. We've seen the use of Kubernetes, started with Docker, obviously, Kubernetes containers, and we've had a lot of success with that, right? There's been a lot of new innovation which has taken place as part of it. We've been able to standardize infrastructure. If you know the analogy we've been using of pets versus cattle. So we've been treating our infrastructure as cattle, so it's more repeatable. We've made multi-cloud as a standard. We've automated our deployments. We have a lot more frequent deployments than what we used to have. When I started, we used to deploy once in a month, and that's it. Obviously, nowadays people deploy several times a day in production. Hopefully, they don't deploy in production on Friday. Absolutely hate it. So, but we've seen this new culture of having a DevOps team. We have few people from the SRE team as well, right? And that's really the things that have taken place over the last few years, which I like to call as cloud native 1.0. Now, we've seen a lot of successes, but it has also come with its own fair share of challenges, as you would probably expect, right? And I really, really love this diagram. What you see over here is this different dots, small dots, and it's trying to get interconnected with each other. And deploying a Hello World application in production is totally different than running a large-scale business-grade application, critical application in production, right? And you slowly start realizing this when you suddenly have hundreds of thousands of different microservices that have been deployed in production, and the architecture in itself becomes so complex that you don't know at times what is going on. I have been, lucky to be part of some of these digital transformations, and at the end of it, I might end up looking something like this, where where I'm trying to explain what my architecture looks like. I'm all googly-eyed. I don't know what is going on. This application talks to this type talks to that. Now, how many of you have sort of experienced this? How many have you deployed stuff in Kubernetes in production? Can I just get a raise of hand? I see a few raise. Okay. I can see the stress on your face. I can see those stress lines. And this is a funny tweet. So one of my favorites, absolute honest update. It says, we replaced our monoliths with microservices so that every outage could be more like a murder mystery. Been there, absolutely done that, right? So the main challenges that we sort of see with this microservices architecture journey is there's very limited or no visibility as to what is going on. We don't have as much eyes on a system when something breaks in production, and I know a few people who might have experiences. It becomes very difficult to sort of pinpoint which exact microservices or which exact application is causing you the pain. The other thing is, typically, there wouldn't be any security. Once you're inside your cluster, typically all communications are allowed. And there's very limited traffic management, which comes as part of it. And also, it becomes extremely complex specifically for cross-cluster communications, right? Especially when you have a multi-cloud sort of environment, those cross-cluster communications will easily age you by 5 to 10 years. So what are the new challenges that we face in this cloud native 2.0 sort of journey that we see a lot of organizations in, right? Now, I do want to highlight some of the important aspects over here, the critical elements of the cloud native 2.0 space that you have to make sure or ensure in this 2.0 journey that you have some sort of an automated deployment process. Typically GitOps, Argo CD, extremely popular. We have to have some sort of way of managing the number of clusters at scale, right? You have to have a way to manage your multi-cluster configurations. You have to have zero trust security, right? You have to manage the security of your microservices. You have to manage traffic which is both inside and outside. In a lot of cases, you might need some advanced capabilities like GraphQL, integration with Lambda, and things like that. You also want it to be Kubernetes native, right? So you want your deployment models to be run by CRDs, your custom resource definitions. Also, typically, you would want some sort of a consistent technology that's there across your stack, and obviously observability, right? You want to have eyes on your system. Now, what I'm going to do in this next portion is talk a little bit about the key concepts in application networking, because this will sort of help you maybe get a little bit more understanding on what application networking does, right? Because what's going to happen is the architecture that you would decide for your application networking is going to dictate how well you can do this digital transformation. So what I'm going to do is I'm going to maybe spend a little bit more time over the next 5-10 minutes to talk about the technologies that have been in the market and how you can have communications between these different microservices and how important this design decision or consideration in your application will drive your business. So in very simple terms, right, what is application networking? Application networking is all about connecting your applications, right? And the typical application stack that you might see, which is fairly standard nowadays, you might have some on-prem servers, right? Something in VMware. Typically, you might have some managed Kubernetes environment like EKS or Azure or GCP or OpenShift, again, is very popular. So is Tanzu. So again, these are probably the usual suspects that you will see in today's infrastructure. Now, when it comes to managing your communication using application networking, there are typically a few ways or few things that you should be aware of how exactly the communication happens. The first one is probably your north-south communication. That's typically people refer to as north-south traffic, wherein from your end users, you let the traffic into your cluster or into your environments. That's your north-south traffic. Then there might be some other sorts of communication, like your service-to-service communication from one pod to the other, from one microservice to the other. There could be some multi-cloud connectivity that you might see. You know, maybe uh, from AWS to GCP or whatever it is. You might also have typically, we see a lot of customers using one single cloud, right? Like maybe AWS. Or a more common scenario that we have seen across production nowadays is maybe have a multi-cloud, maybe have one in AWS, the GCP or Azure, or your usual cloud suspects that you might have. Also, there needs to be a communication from your applications to maybe to some of the legacy systems, right? Like maybe to your VMs and all of that. Maybe you want to have communication to some external services. Again, very common, right? You want to call systems which are outside of your own network. So all this communication, all this interlinking, all this connectivity is what comprises of application networking. Now, few of the emerging trends that we see with application networking, we have companies who have used Kubernetes in production for quite some time, and they, in this cloud native 2.0 world, they've slowly started seeing problems, and we've seen that there are some emerging trends or technologies that can help us with solving of those challenges that we spoke about earlier. Now, some of the emerging trends include we have a lot of maturity with Kubernetes deployment nowadays. It's a lot more easier. SRE teams, DevOps teams are now called platform engineering teams. So there's some rebranding happening there. We've seen a lot of service mesh, right? People have been using service mesh. And I was just talking to someone earlier, and they said that service mesh was really complex for them. But it has come a long way. The new trends that we see, that it is getting standardized, it is getting a lot more simplified than maybe what it was, say, 3 or 4 years back. We've also seen a trend where we have merging of service mesh and API management. And that's something that we've seen happening quite often. So these are the key technologies that are there in this space, in my opinion, which will be here to stay, and which I think should be the choice when you are thinking about something like a service mesh or an API gateway. So I'm just going to touch base a little bit about those these technologies. So this particular portion, like I said, is for the tech geeks in the audience. And like I said, at the end of it, someone is going to walk away with something really cool. So one of the key technologies that we've seen, which will help you in application networking, is an API gateway, right? And typically, an API gateway will act as a mediator between your client applications and the backend services in your microservices architecture, right? Now, if you notice, I've mentioned that it has to be a Kubernetes native API gateway, right? Because typically in cloud native 2.0, you want it to be GitOps friendly, right? You want it to be managed via the Kubernetes CRDs. So this API gateway that you would notice, that's inside your Kubernetes framework, right? And then you can apply things to this API gateways, to this downstream, like things like your rate limiting, your web application firewall, right? Instead of applying it to each and every microservices, you can apply it at an API gateway level. And at the same time, you can maybe connect with maybe AWS Lambdas or other applications which are running on your virtual machines. Now, the choice of a proxy over here is very, very important in your API gateway. And we believe that Envoy proxy is the right proxy for you. So Envoy, for those of you who haven't heard about it, is an open source edge and service proxy, and it was designed specifically for cloud native applications. This was developed by a guy named Matt Klein in Lyft back in 2016. And I really liked his quote. He says, the network should be transparent to applications, right? It donated it to the CNCF project. It is extraordinarily fast and scalable. Works at level 4 L7 network stack. Highly extensible. It has an extensive telemetry out of the box, dynamically configurable. And one of the things that I love about Envoy is it has a very large, diverse, vibrant community. It is an open source community, extremely vibrant, extremely active. And one of the things that I like about Envoy is it is battle tested. So we have seen a lot of major companies use Envoy at scale in production, right? So definitely choosing the right technology, choosing the right proxy, in this case, we believe that Envoy is the right one for you. The other reason why choosing Envoy is very important is once you start this Cloud Native 2.0 journey, you will realize that you would probably need a service mesh. And maybe that service mesh is STO, which is again Envoy based, right? Or some other service mesh, which again might be Envoy based. So what you want to do is you want to have a common API gateway or a common technology for your API gateway and your service mesh, right? So that way it's easier for you to manage. We have the same metric that you can collect for both your north-south and also your east-west, right? Which is your intercommunication using service mesh. So it makes it a lot more easier. So I know I've been talking a lot about service mesh, but let me just sort of define what exactly a service mesh is. In very simple words, a service mesh is a programmable framework that allows you to do three main things: observe, secure, and connect your microservices. And generally, you want the service mesh to be agnostic to the language of your application so that you don't need to do any application code changes. Now, like I said, it's very important to pick the right set of technology. There are quite a few service meshes out there. STO, by far, is the leader in service mesh. It's an open source technology, launched in 2017, and recently it graduated from the CNCF Foundation. So I think back about 2 or 3 weeks back, if anyone has been following the CNCF projects and how they graduate, one of the fastest to graduate in CNCF. We have thousands of big companies using STO in production. So we definitely believe that STO is, again, the right service mesh which is out there. Now, a little bit again, diving into the specifics of how STO works. So if you see on the screen, what we have is service A, B, and C, right? And what you will see is we have something called as the data plane, right? So all the components that you see, they have their own proxies. So if you see Envoy, so the Envoy sidecar proxies, so those are the ones which constitute as the data plane. So this Envoy sidecar proxy, that's the one that's going to be configurable and driven by your control plane, right? So which is your STOD. So we have two basic components: the control plane, which manages your data plane, which basically will be injecting an Envoy sidecar into all of your services. The other technology, if you come down a little bit, maybe at layer 3 or layer 4, is Cilium. And Cilium is, again, an open source software. It's known for its transparently securing the network connectivity when you are using your application services in Docker or Kubernetes. Now, at the foundation of Cilium is basically a very new Linux kernel technology called as eBPF, Extended Berkeley Packet Filter. And this eBPF runs inside your Linux kernel. So what it does is you can apply the security policies at the kernel level itself, right? So you don't have to necessarily change any application code or any container configuration. That's the beauty of Cilium. So we basically spoke about three technologies over here. Now I'm just going to pause here and we're going to have some fun, right? So the technical geeks, who is the first one to tell me what were those three technologies that we spoke about? They'll get a special prize. All right, go for it. Perfect, there you go. Envoy, Istio, and Cilium. Congratulations, you've just won yourself a nice little cloud-native automation with Google Cloud Build. What's your name? Awesome, Keith, congratulations. All right. You want to take a picture? Yeah? Come on stage, Keith. All right. Thank you so much, Keith. Wonderful. So I do have one more surprise, like I said, right? We're probably halfway into this presentation. So there is still one more prize to be won. So if I see a few disappointed, jealous faces, don't worry. There is something for you as well. All right. So now let's sort of shift gears a little bit. We've spoken about microservices. We've spoken about how you've transitioned them over from monoliths to microservices. Now, typically, the application networking challenges that we will see is we might have so many different teams, right? And each one of them has their own way of developing a particular application. It might be in Python, Java, Go, Ruby. Obviously, everyone has their own choice, right? And these applications typically might be deployed in Kubernetes. Now, each framework has its own way of defining things, right? What you want to do is standardize them in some way, because your application will have certain challenges, right? Number one challenge is going to be service discovery. How do I talk to another microservices, or how do I know I even exist, right? There are other challenges that you might face that you want to implement. Things like timeouts, retries, circuit breaking. Even things like having some sort of an MTLS or zero trust sort of a model. Having a standard observability. Now, these portions, if you see, these are cross-cutting across all of your applications. And they are not necessarily differentiating your business value, right? Yes, they are important, absolutely important. But are they adding any business value, right? That's the question that you should ask yourself. Because typically, what you would expect is your developers should do what we like to call as a differentiated heavy lifting, right? So we want them to concentrate on doing what they do best, which is building business logic, without worrying about cross-cutting features like service discovery and observability and resiliency. So what you want to do, like I said, is you want to abstract the business logic away, and you want to have the portions of connectivity, security, reliability, and observability to a separate layer, right? To a separate decentralized application networking infrastructure layer. And we form those, and that's what we call as a service mesh. And then they can be uniformly applied to all of your applications. And they could be, again, written in Java, Python, Go, Ruby, what have you. Doesn't matter. So that's basically where your service mesh typically comes from, right? And so you have your service mesh control plane, and you have your data plane, and then if you'll see, you can connect it uniformly across various applications that you see. And then this way, your developers will be doing what they do best, which is concentrating on business logic. So in the next particular portion, what I'm going to do is I'm going to switch gears a little bit from technology to business, right? Because obviously we might have people who understand the business impact of things. So there are three key things that when you are having this digital transformation journey, that will have a significant impact on your business. And that's security, observability, and resiliency. Those are the three key things that we're going to talk about. And I have some numbers for people who like numbers. I have some reports that we've run from the 2022 DevOps report, State of Observability report. So these are numbers that are actually out there, haven't something that I've made up on the fly. So these actually exist. So in terms of security, everyone understands why security is important, right? But purely in terms of numbers, 93% who have used Kubernetes environment, they've experienced at least one security incident, right? 31% have experienced some sort of a revenue or customer loss in the last 12 months. In terms of numbers, the average cost for this business impact is about $4 million. And this is probably a lot more higher for other high-risk enterprises like your healthcare or financial ones, right? But on an average, 4 million was the business impact for security breaches. Now, resiliency is the second portion that we spoke about. Resiliency, obviously, it means your software services, how long are they up and running, regardless of failure and outages, right? There could be some service outages, network outages, cloud outages, storage outages, all of that, right? But how resilient are your applications? Now, in terms of numbers, for Fortune 1000 companies, this downtime could cost as much as $1 million per hour, right? $1 million per hour. For high-risk industries, it could be very well be like $5 million per hour, right? Like in your banking or your finance sector. But even for a very typical mid-sized company, this could well be like $1 million per year, right? That's a lot of money. Not to mention the business impact of a downtime, right? Goes without saying, low customer satisfaction, loss of revenue, reputation loss, right? And all these are something that you should be very careful about when you are having your digital transformation journey. The other portion is observability. Now, Splunk does a very cool thing. They pull up this report called as State of Observability report. This was last year's report. And what they do is they categorize organizations as leaders, intermediate, and at the bottom, right? These are typically the three categories that they have. Now, 75%, this particular metrics that we have is for the leaders in the companies which Splunk considers as leaders in observability space. And if we'll see, 75% reported an improvement in problem detection time, right? 69% said they had a better MTTR, your mean time to resolution. And again, 68% said they've seen an improvement in development times, and 73% have reported improvement in deployment times. And sometimes this might not make sense, like why would deployment times be better if you have more eyes on the system? But it kind of makes sense, right? Let me try and explain this. Let's say if you're an organization who does frequent deployments, you will have a much better confidence in your releases. You will have a much better strategy of doing rollbacks. and you will be a lot more proactive, right? So instead of someone who does like one deployment per month or a year, right? You're going to have a lot less outages, which is obviously going to translate into money. It's all about money, isn't it? So this particular number, this talks about the annual cost of downtime, which is associated with your business critical internally developed apps. And if you see, there's a stark difference between what we consider as the lead beginners in the observation space to the leaders, almost like a 10-time difference, right? So 2.5 versus 23.8, almost like a 10-time factor. So clearly, it's very important that when you are having this digital transformation journey, you are aware of this business impact. Now, over the next 10 or so minutes, what I'm going to talk about is specific use cases on how application networking can help you in this particular space. The first one is probably the easiest one, which is probably the most talked about one as well, which is MTLS or Zero Trust Security. Now, when you're talking about your normal server-side TLS, you have someone called as Alice, who is probably a web browser. You have Bob, who is maybe someone like a Google or something. And this is your normal TLS that you do, that you open a browser, Bob, who is Google, will show its certificate, and then Alice will be, all right, that's fine, and you'll have a secured communication. Now, mutual TLS is kind of similar, just that you will validate both the parties. So you'll validate Alice as well as Bob. So both have to provide their identity, and both parties have to say who they are, right? So and they can talk to each other in an encrypted communication sort of a manner. Now, why is this important in Kubernetes? Now, the default state of Kubernetes is once you are inside the cluster, the default state is you will be allowed to talk to whoever you want. And this, again, is a very classical pattern, also called as the castle and moat architecture that you might know. What this means is that if one of the pods or services is compromised, you are subjected to being compromised for all the other pods that you have. So the most common best practice for this, to avoid this sort of a problem, is called as your MTLS or your Zero Trust Security, right? So this is the desired state that you want to get to as an organization. So great, I mean, let's do this, right? Well, not so fast, because we've seen statistics that say that it's not that easy to do, because if you're going to do it manually, that's going to cost you a lot more outages. So what you should be having is an automated way of managing those certificates, right? Managing those MTLS. And STO does that out of the box. So your STO control plane, that can give workloads certificates to your workload entries. So if you see over here, your STO control plane can then tell or give those certificates to your Envoy proxies, and your Envoy proxies in turn can now encrypt the traffic which is to and fro. So it can have that MTLS portion going that we spoke about earlier, right? And it does that in an automated manner. Even the certificate rotation, that's fully automated, done automatically for you. The other portion when it comes to security is at the API gateway level. We saw API gateways earlier. Now, a lot of organizations, they want to have authentication and authorization at the ingress level itself, at the north-south level itself. Could be via your JSON Web Tokens, your JOT as it's called, your OPA, your Open Policy Agents, and having some sort of a data loss prevention or WAF, which is your Web Application Firewalls or rate limiting in place, right? So that's the security portion of things. Resiliency, obviously, when it comes to resiliency, there are going to be failures, right? Now, how do you manage those failures is what will differentiate. Now, the common strategies to mitigate this is typically have some sort of a timeout. So if a particular service is not responding, don't just wait on it, right? Set a timeout limit. If it doesn't respond, you can avoid the cascading failure. Same goes for retries. Now, this is typically for your transient sort of errors. Maybe it's a network blip. Maybe it's something is unavailable for a very short period of time. You try it once, doesn't work. You try it second time, doesn't work. You try it the third time, works. Right? So you can have those retries set in your at your application networking level itself, right? Same goes for circuit breaking. If there are going to be some degradation, you can have your services degrade gracefully, right? And all of this can be managed at the application networking layer itself rather than managing at your code level. Now, when you talk about digital transformation, observability can really drive that competitive advantage using what we like to call a uniform approach, right? So you can sort of understand your traffic patterns. Maybe there are certain days or certain times where you get a lot more traffic. Maybe you can understand proactively how your services are behaving. You can anticipate those outages. You can audit those accesses, which is very important for some of the industries like banking and finance and all of that, for regulatory reasons. So with that, what you can see is that we can have some sort of a standardization in your observability. Same goes for metrics and access logging, right? Because if you're going to have some sort of a envoy proxy or some sort of a data plane proxy in front of all of your applications, you have a standard way of managing your metrics and access logging, right? And you can then put them to either to Prometheus or Grafana and manage them in a much more standard sort of a way. All right, so very quickly, can someone tell me what are the 3 business drivers that we spoke about, right? And that's a quiz question. Spoke about 3. All right, come over. I know you've been eyeing this prize, so congratulations. What's your name?
Chan.
Congratulations. All right, so like Chan rightly said, those 3 things that really drive your digital transformation is security, observability, and resiliency. Now, very quickly, I do want to touch base about what we do here at Solo, which is our path to our Glue platform. Now, we spoke about the north-south traffic. We spoke about the east-west traffic. So we do have a common platform, which is called as the Glue platform, which can help you with your north, south, east, west traffic. So you have your API gateways, you have your service mesh, and you also have the networking component, which is again Cilium based that we spoke about. Because one of the things that we've seen as a challenge when it comes to adopting a service mesh is, I had spoken to one of the people earlier as well, it's very complex, not too many engineers know it, so there's a shortage of expertise and engineering in that particular space. So we at Solo, we have this Glue platform which can help you with those capabilities, and at the heart of it are those 3 important technologies that we spoke about, right? Envoy, S2, and Cilium, all open source products. So using our Glue platform, you can have an API gateway, you can have those zero trust networking, you can have your observability, you can have multi-tenancy. So if you want to talk across multiple clusters, you can quite easily do that. And all of this comes out of the box, right? So that undifferentiated heavy lifting that we spoke about, that initial reluctance of using something like an STO in the organization. So that is taken away when you use something like a Glue platform. And top of it, we also have enterprise support. If you need any help running this in production, we have people who are literally the experts at it, right? They have built the product. They are part of the open source community and have been doing that for a very long time. So with that, if you are interested, if any one of you is particularly interested in learning these technologies like Envoy or STO or Cilium or eBPF, right? These are, like we've mentioned, the cutting edge technologies which are out there. You can do all of that for a very small fee of $100. No, I'm just kidding. It's absolutely free. You can go to academy.solo.io. All of that's absolutely free. I can learn more about these open source technologies. So mark that site, academy.solo.io. There's also an ambient mesh workshop that we're going to run later today at 4 o'clock. If you're interested to know more about that, you can do that as well. So finally, I want to say thank you so much. You've been an absolutely wonderful audience. And hopefully, you have learned a little bit about the digital transformation. In summation, I just want to say, when doing digital transformation, application networking is going to be the key which can drive your innovation and acceleration. Thank you so much.